So objective 16, I have it written on the board over there too. So objective 16 is interior and exterior angles of triangles. So the inside triangle of the triangle and the outside part, like if lines are extended. Okay. And then 18, objective 18 is the Pythagorean theorem. Okay, which is our first vocab word that we have up here. Okay, so Pythagorean theorem is a squared plus b squared equals c squared. Okay, which means you're working with a right triangle. So what makes a triangle a right triangle? How do we get 90-degree angle. Okay, so instead of writing 90, they put a box representing the 90. Okay. In that formula, the only letter that really matters which one's which is the C. And the C is always, and that's why there's an arrow there, is always opposite of the right angle. Okay, and we call that the hypotenuse. It's always the longest side opposite of the 90 degrees. Okay, so you're writing that. And then the next one down is interior angles of a triangle. All triangles, regardless if it's acute, obtuse, isosceles, scalene, all triangles on the inside adds equal 180. Okay, so write those two things down and then we're going to move on to the next vocabulary. Okay, we good? Okay, next set. Okay, so exterior angle, and then rather than triangle, it's a good symbol. So exterior angle triangle sum is always 360. So that if you remember last year, remember us cutting out pie pieces? Remember doing that? And so we had like, besides triangles, we had a four-sided figure. We had I think we had a pentagon, and there was one other one. And we cut out the outside pie pieces. Okay, and then you put them together and you put them on your notes and taped them together, and all of them fit together to make a full circle. So outside angles, regardless of what the shape is, are always going to be 360. And where that's coming from is they just extend each of the sides. Okay, so like extend this, okay, extend this one. Okay, so these are the three exterior angles that have to equal 360. Okay, and the reason why there's numbers on there is if you notice when we add those, it still doesn't matter, okay, what the outside one would be, because if this extends, what does this angle and this angle need to add to equal? 180. Okay, so if this is 60, then I'd subtract it from 180 to find this one on the outside, right? So that means all of those would be that same thing. You add it together, it gives you 360. Okay, so it doesn't matter what type of triangle it is. When you extend it, it makes a straight line. This would be 60, this would be 60, and this one would be 80. So we add those together. Okay, so the inside of triangle should add to equal 180. The outside is 360. Okay, anybody still writing? This last one before we go to make it. No, use sniffles. I see you're gonna make it sniffles. Just jam some tissue there. Just leave it. Okay, we good? Okay, so that first triangle that sides, two of the sides are marked. So as a flashback to previous section, when sides are marked with two of them the same, what type of triangle is that? Isosceles. So if two sides are equal, what do you think is true about angles? Two angles are also, okay? So there's going to be some where they're going to give you one of the angles, okay? So on these, on these, they'll give you this one right here, and they're going to want you to find the other ones, okay? Well, all the other ones, they're going to give you two of them and ask you to find the missing one. Well, when you have two of them, you can add them together and subtract them from what? 180. But when it's like this, if I had, say, I'm just trying to make this easy on us. So if I said this was 80, which is not, it's probably more cute than that, but if I said this was 80, and they're asking you to find all the other angles, what would I do?
Subtract 80 by, or 180 from 80, and then you would divide by 2.
Divide by 2, because you have two angles that are going to be the same, okay? So that would mean 100, right? 100 divided by 2, that would mean that this one would be 50 and this one would be 50. So don't think, hey, they didn't give us enough information. Look at the triangle, okay? All the other ones will have two angles, and you're going to find your third one, because they all should add to equal 180, okay? So isosceles triangle have two angles that are the same. Okay, so triangle exterior angle theorem, the sum of the two remote interior angles is equal to the exterior angle. So you remember we talked about this last year as well. When we use a remote, we're not using a remote for the TV that is sitting right next to you, right? We're using it for across the room, hopefully. I don't know, some people might not, okay? So what they're talking about is if I have one of my sides extended, so like this one right here, one of my sides has been extended, so this one goes out here. This exterior angle is equal to the sum of the remote interior angles, not this one, okay? Because we're not going to use the remote for the one that's right next to it. It's the other two angles, okay? So sum means to what? Add. So if I add these two and they ask me what this one is, then I just add them and that's what that is, okay? If not, there's a longer process. I can add these two and subtract from 180 to find this one, and then subtract it from 180 again to find that one, because this makes a straight line. Okay, shortcut is just you redid it, add those two, and that's what that outside one is. Okay, all right, so that's how you find your exterior angle. Or they might give you the exterior angle like this one, and give you this one, and you're trying to find this one. So if this was 90 on the outside, which it's not, just make it easy. If this was 90 and this was 50, and they ask you for that one, that would be what? 40. Because the two of them add to equal what that outside one is. Okay. Or you can subtract that from 180, find that one, add those two together, subtract from 180 again, and find that one. So there's multiple ways to find this. Okay, we're writing our first one. Okay, and this is using the Pythagorean theorem on this one. So number 79, you're going to write solve for x and just draw a right triangle. It doesn't have to be that exact right triangle. Just draw a right triangle. One side is x, the other side is 5. And then 13 for the long side. Okay, and this is when we're going to need our calculators. Okay, we ready? Okay, so if you recall back at your very first thing you wrote, the Pythagorean theorem, I said the only one that really matters is the C, okay? Because the A and the B, they can switch between each other. It doesn't matter which one's the A or which one's the B. So in this drawing, which one is the C? 13. Okay, so our formula is A squared plus B squared equals C squared. We just said that C was 13. So I'm going to start noticing. Does not matter of these which one's my A or my B. So I'm just going to start with X. Okay, so X, I'm going to need to square. And then my 5, I'm going to need to square. Okay, well, X squared, you don't know what that is yet. What is 5 squared? 25. Okay, what is 13 squared? Okay, so now we're just thinking of algebra and we're solving for x. So to get the x by itself, I have to move the 25 over to the other side. I'm going to go 169 minus 25. Okay, so now we have subtract 25, subtract 25. So now I have x squared equals 144. Okay, now up above in the question it says solve for x, not x squared. Okay, so I still don't have it just x. So the opposite of squaring something is to take the square root. Okay, so when I take the square root of this side, the square gets rid of square root and leaves the x. But what I do to one side, I've got to do to the other side. So that means I have to find the square root of 144. Okay, if you don't know, then you should have on your calculator the square root button. Some of you have to put the number in first, then hit it. Others have to get the square root first and then put the number in it.
So,
okay.
Just basically, you're making it all squared, and then once you get it down to x, you just put it back to what it was.
Right.
Re-square it, opposite.
Right. Okay, and they just want it in. Anybody can help finding it on their calculator so you don't have to use it. 144. Okay. So, you're going to hit the second button. And then where that and then 144. Okay. Anybody else need help? You good, Tori?
Yeah, I was trying to see if I could do it online. Yes, you could.
You need help? You got it? Okay. All right. So we're going to try it again. Except we have a story problem versus a drawing for us. We have to know which is which. Okay, so you're writing this out. Okay, so it reads 86. A rectangle has a length of 18 inches and a width of 13 inches. Find the length of its diagonal. Okay, so drawing representation, we have a rectangle. Okay, a rectangle has a length of 18 and a width of 13. This is my A and my B. It really doesn't matter which one's which, okay? So I'm just based on drawing, I'm gonna put the 13 here and the 18. It really doesn't matter. Okay, I could put the 18 here and 13, but I have a smaller side on this side. So. Okay, so now they want us to find the length of the diagonal, okay? And I could do this all the way around if I needed to, okay? So it doesn't matter if the diagonal's going like this or if the diagonal is going like this, okay? When I did that, I made two, what? Triangles. What kind of triangles? Right triangles, okay? So really, we're just gonna look at one of them because both of them are the same triangle, okay? So they gave me the A and the B, and if I'm finding the diagonal, what letter am I finding? The C. Okay, so I'm writing this as 13 squared plus 18 squared equals, I don't know what the diagonal is squared, which is the C. Okay, so 13 times 13 is going to give me 169. Okay, and then 18 times 18 is 324. Okay, so then I'm going to add 324 to 169 for 93.
Oh, wait.
Okay, 9, 4, 6, 7, 8. Okay, equals what the C squared is. 493. Yep, I just got to look to see what the. You got what? 22.2. Yeah. And it's approximate, right? Because it keeps on going. Yes. Okay. So C is 22.2. And you'll see when you do the multiple choice thing, they'll have an approximate. So it looks like an equal sign, but it's like they kind of curve it. That just means it's not exact. Okay. Okay, we good? Okay. The next.
So that would be the answer then?
Yeah, 22.2.
Oh, so you only have to do one set to get it.
What do you mean one set?
Like, take, so.
It's the two of the same triangles. It's a rectangle. So rectangles, the opposite sides are the same. So the diagonal on this triangle is going to be the same because it's still squaring the 13 and the 18. Does that make sense?
Yeah.
Okay. That's a good question. Okay, in triangle ABC, so I'm just going to draw a triangle. I don't know what it's going to be yet. Okay. A, B, C. It says in triangle ABC, the measure of angle A is 13. The measure of angle C is 21. Calculate the measure of angle B. What did we say triangles add equal on the inside? What? 180. Okay, so we're going to add those two numbers together. So I'm going to go 13 plus 21, and that gives me 34. Okay, so 13 plus 21, and that gives me 34. But then I'm going to do what with that number?
Minus 34.
Right, you're thinking of sides. This is the angles. Minus what?
34.
From what?
180.
180. Okay. So all angles on the inside of triangles add to equal 180. So if I have a missing one, I can add the two together and then subtract it from 180 to find out what that missing one is, which gives you 146. So the measure of angle B is equal to, I'm not worried about the degree symbol, but on a test you would see that 146 degrees. Obviously our drawing is not a representation of that. We just sketch it. Some of you won't need to sketch it, you'll just know, oh, these are angles and they're supposed to add to equal 180, you don't need to draw it. Good? Okay, so inside add to equal 180. What is outside of equal?
360.
Okay, just check. Okay. Because that's where we're heading. Okay, so I just want to point something out, so hopefully this doesn't throw you off. Typical one that you had on your notes, right? We had a triangle and we extended the side, and then we had a triangle and we extended the side, okay, and then we had a triangle and we extended the side. So usually it's this one and this one and this one, right? Okay. This one they put right next to each other, but what do I know about these type of angles? They're vertical and they're what? Vertical angles. So if I had an angle like this angle and this angle are what? Congruent. So really they are doing that. They just put it on this other side. I think trying to think, that doesn't look like that's in the right spot. So typically it would be on that other side, but it is. Those are vertical angles when they cross it like that. So typically this line would be there. Okay. All right, so outside angles we just said add to equal. Okay, so you're going to add those two together. So you're going to 123 plus 98. 221. Okay. Is it? Yeah. Okay, then I'm taking that number and I'm going to subtract it from 360. Yep.
I got the same answer, just very long in the process.
Hey, that's okay. There's,
Because I
core.
did, all I did was
You have
did
10
like
different ways to
90.
do things.
I did 98 plus 181 this way. Alright, so 98 minus 180 and like 123 minus 180, add those together. And then,
Gave you that exterior angle.
yeah.
Yeah. So he used the exterior angle theorem. So he found this angle, right, by subtracting 180 because it's on a straight line. And then he found this angle. And then he remembered that these are the remote ones that add to equal that one.
Oh,
So again, Common Core, there's probably 10 different ways to do one problem, but so some just take more steps than others. So yeah, if you catch that, that's great. Good job. Okay, I think that was it. I hope.